Welcome back to mini lecture part 2 of the introduction of oxidation and reduction reactions. In this video, we're going to go through and look at how to assign what is being reduced and what is being oxidized. So we're going to start and look at this reaction, and if you look at it, it is a single replacement. Well, we know now that single replacements are going to be oxidation reactions. So I'm going to assign my oxidation numbers. So again, the same way that I always do, this is going to be a -2, and it has to be equal to 0, so that's 6. So what can I multiply by 2 to get +6? And that would be a +3. So my iron is a +3. My oxygen is what I would assume it to be. This aluminum is 0. Aluminum on this side is going to be, and I'm going to assign it the exact same way. We get a -2, which is -6. What does the aluminum have to be? It would have to be a +3. And then this is going to be 0. So we have assigned our oxidation states across. Well, the oxygen is staying the same, so I'm not going to mess with the oxygen. But let's look at my iron. The iron, I'm going to put a box around it, is right here, and the other iron is right here. I'm going to bring it down. So I went from a +3 oxidation state to a 0. So the only way that I could do that is if I was gaining electrons. I would have to gain 3 electrons to cancel that out to make it to be a 0. So gaining is going to be GERS. So now let's look at my aluminum. And I'm going to circle my aluminums. And this time I'm going from the reactant, and it's 0 to a +3, so I have to be losing. So that's Leo. So we go through and you say, well, what is being reduced and what is being oxidized? The aluminum, and we always look at my reactants. So the Al is oxidized. The Fe2 and the O3, the Fe would be what is reduced. So if I was to say, well, what's being reduced, it is the Fe3 ion. And that would be how I would go through and say what is being oxidized and what is being reduced. Now, there's a little bit of nomenclature in here that just really destroys people on the test. It'll ask you what is the oxidizing agent or what is the reducing agent. And guys, if this, it's always going to be your your reactants. It always has to be in the reactants, which is left of the yield sign. In this case, we look at it and you see that the iron is being reduced, so the aluminum must be the reducing agent. Down here we say the aluminum is being oxidized, so the iron +3 ion has to be the oxidizing agent. So the oxidizing agent is what is causing it to undergo oxidation, which is what is being reduced. So what I would like to do is I would like to do A and B, and then I'm going to let you do C by yourself. Okay? So we're just going to go through, and I'm going to go through this one pretty straight up. This is 0. This is 0. All molecular gases or solids will have 0 oxidation state because they're already stable. In the hydrogen oxide, or the hydrogen oxide, the water, I get a +1 and I get a -2 oxidation state. So if I go from my hydrogen to the hydrogen, I'm going from the 0 to a +1, so I had to lose an electron. So that is Leo. In the oxygen, I'm going to circle them. It's going to be an oxygen. And it's going from a 0 to a -2. So to get a -2 charge, you had to gain. And that would be Leo, the line says Ger. So what is being reduced? The O2 is reduced, and the H2 is oxidized. That's it, guys. I'm going to do the next one. I just want to go right through it, and then I'll let you do the third one to see if you have any questions. So again, I'm assigning. I got a solid, so that's 0. This is +2. This is +2, and this is a solid, so it's 0. So I'm going to go from my zinc over to this zinc, and that's going to be a 0 to a +2, so I'm losing Leos. And then I'm going to go from a +2 over to a 0. So I had to gain electrons in order to go from a +2 to get it to be a 0 oxidation state. So losing is oxidized. So oxidized is going to be the copper +2. The reduced is going to be the gaining, and the reduced is going, ooh, I did that backwards, didn't I? Sorry, guys. The over here is what is being, I just followed my line wrong. My zinc, so I needed to put a zinc here. And this copper +2 is being reduced because it's gaining. All right, with that being said, what I'd like for you to do at this time is to go ahead and do the very first C and see if you can assign the oxidation numbers, determine who is being oxidized, who is being reduced. All right, thank you.